So basically, this is this part that should be simulated because this is the place where samples or serums or vaccines in their container need to be cooled. So to be cooled, when we apply electricity, we have heat. Now the heat need to be dissipated, right? So this is shown that when the thing is well insulated, let me show you. When there is no insulation, when there is no insulation, like when the temperature is high, so we will show you the simulation. You solve it. It is running.
Hi everyone, my name is General Anthony from Congo Brazzaville. I'm a fourth-year student. I'm working in this project with my partner. Introduce himself.
Hi everyone, my name is Iressef. I'm a mechanical student at DAUST at the senior level. Well, the project is about the the bio bank. Which, when we talk about biobank, is about electrothermal cooler. Well, why we call it electrothermal cooler? Because the project is about cooling samples by using electricity. Actually, that is the project. Now, regarding the problem that we wanted to solve, is we know like people have a hard time to firstly to conserve their samples. When you talk about samples, you got biomedical or serums or vaccine samples, and also they do have issues to transport them. Recently, we all heard about that the Senegalese vaccine, the COVID-19 vaccine which was dedicated for the population, expired. The main cause is a lack of good conservation. So this project is here to solve that problem and all those challenging related to those issues regarding the conservation and the transportation of samples to maintain a good integrity and to avoid delay regarding medical samples.
Okay, there is our prototypes. It's a thermoelectric cooler. We have fans, um, heat sink, and we have here the place we put the samples. So, first of all, the fan is used to prevent overheating, and the heat sink is here for the heat transfer, actually. And we have also insulators, which is made of those kind of material, and the battery, which gives the power to the whole device to work. Nevertheless, we have this one. This is a digital thermostat used to control the temperature, and the temperature is between 2 and 8 degrees Celsius. Furthermore, we use the Peltier effect, which converts electricity to a difference of temperature. Those are the part of the device we printed. So we design all those stuff, and this is the cover, the handles, and the whole box.
Well, mostly when we talk about like projects, we tend to like to come up with the social and the business impact that projects gonna have. But you know, like people in the medical field, they're spending at least millions to conserve or to transport their their medical samples or serum or vaccines. Now, if you come to solve that problem, like it means you hurt two birds with one stone. Let me break it down. It means you can be able to do the right conservation by maintaining the right temperature, but also you could be able to transport the sample correctly. And now, this is a prototype. It is highly reliable, and also we can be able to instead of spending millions, because if you want to do a transportation of vaccine or samples or serums, for instance, in Gambia, either you need to spend a lot of money regarding the consultation with the cooling part and also the transportation and the integrity. Now with these projects, we'll help you have these once. Now if someone wanna work in this project, if you wanna make it bigger, we can make a lot of money. Now the millions that they're sending into airplanes regarding the transportation, into ice or other cooling system regarding refrigerator or AC. So you can use this project, which is highly reliable, and it can make you save money and also achieve your goals.
Actually, we spent it was about 3 months. 3 months, because we first had to make sure that all the connections are well done, the wiring, and also we need to make sure that the temperature was going below, achieving the 2 degrees Celsius. And then there was a part of designing. I took care of it. And finally, we were doing the simulation that he could show and explain about.
Well, regarding the designing, it doesn't take that much time because we've already taken CAD classes last year. But when we come to the simulation, we have to use a software which is called ANSYS. So that software, we're supposed to take it next year or next semester probably. It's a 5-year program software. But regarding the needs of the project, I have to go through it. So I took a whole lot of courses within 3 months to be able to do the simulation and to show the values. So that was the hardest part regarding the simulation.
So for the skills, we used 2 main softwares. SolidWorks for modeling the whole device and ANSYS for the simulation. And we add also some knowledge about heat transfer and thermoelectric. It was about first the battery, because this device take 12 voltage and 3 amp to work. But the battery we're using didn't have enough amp. It was about 2.5. You see, there is a huge difference between 3 amp and 2.5. Because of that, our digital thermostat wasn't working well. And we managed to find the right battery, which is this one. It can take at the same time 24 voltage and the 12 voltage with 3 amp and 5 amp.
Another challenge is for me to be able to go through ANSYS, because normally you're supposed to have a teacher who is supposed to teach you the software. You have to do, it has 2 major parts. You have to do a theoretical part, which is the classes, and then you will do the practical part. So for me, going by myself, I have to learn all those stuff through online classes. From there, I do the simulation before I get to start with our simulation. That was a very challenging. And still, there's room for improvement, but we are satisfied regarding our simulation. Well, for the project, our next step is going to be able to track. We have to put like GPS, so that, for instance, when Institute Pasteur, when Institute Pasteur or Iressef are supposed to deliver like a samples or vaccine or something regarding to medical analysis to somewhere, they should be able to be in their office and be able to see that, able to track the sample, because it is something which is highly important, because for some security reasons, this need to be tracked and it need to be we need to see the GPS and the localization of the sample until it arrives to the destination. And also, tracking this will allow them to see if the car stuck somewhere, to know what are the main reasons. For another for another perspective, we did not decide it yet, but we're thinking about it. You know, this is using electricity, so the device is small. Now imagine the device, we're gonna make it bigger, and also we using cars to transport it, right? If you're using cars, so the electricity, it might be some case that needs to be considered. From there, we're thinking about if we can see, we can use the solar to power it or not. But that's still a perspective, but we are thinking about it and see if it is going to be possible or not. Yeah, those are the perspectives.
First of all, I think without doing this project, I wouldn't be able to learn about thermoelectric cooler because I didn't have any device or any clue of how is it working. So it also helped me to improve like my knowledge about CAD drawing because always trying or learning by doing is a better way to achieve a new skill. And I think it will help me with the future and like the upgoing situation I could face.
Well, for my case, this project was a real life experience because I never, before I worked in this project, I never thought that mechanical engineer can bring something in the medical field. That was something that I wasn't aware of it. For me, when you talk about medical field, you'll be like computer scientists by using deep learning or such like that. But for a mechanical engineer, bringing a solution to a medical field, this was my first time, and it helped me discover many more things ahead of us that I did not know really. For me, like mechanical engineers work on like companies in aviations, in aeronautics, and other fields, but mechanical engineering be able to work in the medical field. This was the project that opened the door for me, and also it helped me add my skills regarding CAD drawing, also enhance the simulation because CAD drawing, engineering drawing is something very important. But to reflect the real life application of the drawing, you need to simulate it, and only the simulation can do that. So, and also through this project, we will keep on learning because it is not. We also learn about the electric, about the
Yes,
electric part.
of
Because as a
course.
mechanical engineer,
We don't have any.
we don't have any tools or any. We don't put interest. We don't put interest in electrical stuff. But now, when you're working in a project, when the electrical skills are needed, you need to take a look at it and do some documentation, and that was really helpful.